What is up, y'all? Today I want to teach you how to find the volume of any prism, not just a rectangular prism. So please make the title on your next math page, notebook page exactly this. When you have done that, mark that page. Close that notebook, turn on that brain, put away those distractions, and concentrate till we get to we do. All right, lots to connect. So first, we talked the other day about prisms in general. Just a reminder, prisms have two bases that match. So like in this case, this is a triangular prism. It's got a triangle here and a triangle here. We would call that its base. And then it has rectangular sides. So you'll notice even on this triangular prism, it's got these two triangle bases here. But then all of the other sides, if you look carefully at them, are rectangles. We refer to that as its height, even if it's laying not on its bases. So like this triangular prism, it's sitting on a rectangular side, not on its bases. This triangular prism here, it's sitting on its bases, so the two triangles, and then we would call this its height. And even if it's laying on its side, we do that too. So this is a prism with an octagon or a pentagon side, it looks like. We'll count rectangular prism, hexagonal prism, pentagonal prism. It's just all about what those bases are, makes it a prism. These are not prisms. Like you'll notice this one, it does have a triangular base here and a triangular base here, but they don't match. So its sides aren't rectangles because of that, so that's not a prism. Same here. This is called a pyramid. It has one square base, but not a second, so that's not a prism either. This is not called a prism. This is called a cylinder, but it works like a prism. It's got two bases that are both circles, one here and one you can't see back there, and then a wrapped around rectangular side. So it's not technically a prism, though we are going to talk about those a bit today, even though it's not technically one. Another connect, volume versus surface area. So remember in our title that we're talking volume. Volume is how much space is inside of a prism, how many cubic units it could be fit into it. Whereas surface area is kind of the area of the outside of it. So you would kind of unfold it and say, okay, find the area of that, find the area of that, and so on. Or if you want to think of real stuff, volume, like in these shipping containers, is how much would fit in it, is its volume. How much can it hold? Its surface area is kind of like how much metal would you need to make it on those six sides. So we're talking today about volume. And what you've learned in the past about volume is how to calculate it kind of like this, where you say, all right, how many of these cubes could I fit in it, into this rectangular prism to fill it up? So we measure in cubic units. How many could we kind of fill it with? And that gets annoying, obviously, to try to always be drawing in little cubic units. So as many as the case in many geometric things, there was a formula, and we just kind of said, okay, well, if you'll notice, in one layer, if I go at the bottom, this one you could fit 1, 2, 3, 4, 5, 6 this way. And then you can fit 1, 2, 3, 4 that way, which means on the bottom there would be 24. And then you could fit up 1, 2, 3, 4, 5, 6, 7, 8. And that formula of length times width times height, 6 times 4 times 8, that would give us the volume with a formula, which is nice. So volume equals length times width times height. And that's kind of where you've been so far with volume. So let me show you a few things today. So for a rectangular prism, which you dealt with in both 5th and 6th grade, we know that typical formula, volume equals length times width times height. No big deal. So this one, it would be, doesn't matter which one you say is the length, the width, and the height. It's just remember that there's 3 dimensions. So I'll just say length, width, height. So this one, it would be 4 times 5 times 3, which is 20 times 3, which is 60 cubic, whatever those are. There's no unit labeled. That does fine, and you can use that. I want to show you a new formula that is both shorter and is going to help us on different prisms that are not rectangles, that don't have a length and a width. So I want you to notice here, this part down here, these first 2 parts of the formula, they're going to make the area of this bottom rectangle. If I do length times width, then I get the area of the base here, of this big base thing. It's a rectangle, and if I multiply it length times width, I get the area of that base. So what we do sometimes is we just say that that is one piece of the formula, and we combine that length times width into a big B, capital B, which stands for the area of the base. It's the same thing as length times width, because length times width is how you find the area of a rectangle. So it's like area of the base, and then we bring down and just continue with the height. So that's a new volume formula that's shorter. There's only two things in it, and it's going to help us on other kinds of prisms. So if I find the volume with the same thing, I'm saying, okay, let me find the area of this rectangle that it's sitting on. So that is a rectangle that is 4 by 5. So the area of the base is 20 times the height is 3, and I still get 60 cubic units. So I'm going to use that formula for other figures other than rectangular prisms. That's why I wanted to show it to you. So let me show you one on, say, a triangular prism like this. If we wanted to find the volume of this, we can't use length times width times height, because triangles don't have length and width in the same way that rectangles do. So that doesn't really help. And so we can't use that formula anymore, but we can use that other one I showed you for other prisms where we say we want to do the area of the base, which we do with a big B, times the height. So triangular prisms, you'll notice this one's not sitting on its base. A triangular prism has two triangle sides, which we call its base, even if it's not resting on those sides. And that can be a little confusing. Sometimes people prefer to think about triangular prisms oriented this way. That way it's like on the base. And that way the height is actually a height here. Because you'll notice when I orient it this way, I'm going to find first the area of the base here, and I'm going to call this a height, even though it's not oriented a way where that's like up, like a height, like we're used to. So that can be a little weird. So sometimes people like to turn their triangular prisms upright, and that's okay too. So that's what I'm going to do here. So I'm going to find the area of the base triangles and then multiply by the height. So triangles first, define that area of the base. Remember, triangles, you do base, their length times their height, or their base times their height, however you want to say it, divided by 2. So this triangle here, its base or its length is 10. So that's 10. Its height, remember, its height is not this way. Its height is straight up from the bottom. So its height is this, 8 3/10. And then I'm going to divide that by 2. So 10 times 8 3/10 is 83. Divided by 2 is going to be 41 and a half. So that's the area of those triangles. I do base 10 times height divided by 2. So I get a area for these triangles of 41 and a half. And then we're going to multiply all that by the height of the prism. So in that case, it's 14 here. That I'm just going to use a calculator for to speed it up. Find that. 41 and a half times 14. So that triangular prism would hold 581 cubic centimeters. I can even do that with cylinders like this. I can use that same formula, volume equals the area of the base times the height. It's just in this case, the area of the base, I'm going to need to find a circle. And I know how to find the area of a circle. We've learned that already this year. It's just all about how I do that. You find the area of the base, then you multiply by the height. So in this case, the area of the base, remember, for a circle, area is pi times the radius squared. So let me calculate that. So for this particular cylinder, the radius is 4. So I'm going to do 4 squared times pi. And so now these bases, the top or the bottom, doesn't matter, have an area of 50 and 24 hundredths. times the height. So the area of the base is 50 and 2400ths times the height is 10. I know how to multiply by 10 with no calculator. I'm just going to have a decimal shift. So it would hold 502 and 4/10 cubic meters. So I'm going to do here, I'm going to stop this I do video here. We're ready for we do. To make sure I don't have to super speed rush through those steps, I'm just going to stop here and make a part 2 video for we do. So tune into that next.